So, to find A1, we know that A3 is equal to A1 times R to the n minus 1. A3, they already gave to me, 63 over 4, equals A1 times 3 halves to the 3 minus 1. 63 over 4 let's see. So any questions on getting A1?
Why is it 4 only?
Okay, because I just multiplied by 4 on both sides, so I could cancel out this 4. This is like 4 over 1. So this goes right here. So A5 equals 7 times 3 halves to the 5 minus 1. So A5 equals 7 times 3 halves to the 4th. Simplifying. There we go. Eddie.
After performing where's the R?
Right here.
Yeah.
Okay. So you good with the 9a over 4? So 3 squared gave me the 9, and 2 squared gave me the 4. Then on both sides I multiplied by 4, so I could get rid of the 4's that were downstairs. So 63. Does that work, Eddie? Okay. Other questions on this, Edgar?
And then it was way before, but
That's fine.
Um,
Previous page.
yeah. So we had 667. No, 701 over.
Right here, 63.
Yeah. Why couldn't we just do the fancy one on the 30?
Okay, because that's used when we're adding. Here we're multiplying. So they use the fancy one when you're adding or subtracting to get a common denominator. When you're multiplying, you do not need to find a common denominator. Question. Other questions on this problem? Okay. Let's go to number 32, please. Number 32. All right. So number 32. All right. It says a ball is dropped from a height of 9 feet. So here's the ground. The ball is dropped from height of 9 feet. So that's this so far. Then it says the elasticity of the ball is such that it always bounces up. Think about a ball, it bounces down and comes up. 1/3 the distance it fell. So it fell 9. It's going to come up 3. And it'll come down 3, of course. Whatever goes up has to come down. Now it's going to bounce back up 1/3 of the distance it fell. So it'll bounce up 1 foot. Then come down 1. And then come up 1/3, come down 1/3, and so on, and so on, and so on. Questions on the future. And they want us to find the total distance traveled. Alright. Now, if they wanted to know how much distance it's traveled the instant it makes the first bounce, what would your answer be? Right here?
9.
How far has it traveled? Is it 9 feet? Because it says the instant it makes the first bounce, hits the ground, so 9 feet. Look at the second bounce. What would this be? How far has it traveled here? 6 plus 9, right? It already came this. So in total, because they're on the total distance traveled, 15 feet. The third bounce, well, 15 plus 2, so 17 feet. Are there questions on this much? Okay. Now, of course, if they'd asked me for the first, second, or third bounce, it's done right here. They might ask for the 20th bounce, and we don't want to sit here and add this. There must be some formula. And let's take a look at that. So if you notice these distances right here, we have 9 plus 3 plus 3 plus 1 plus 1 plus dot dot dot. This is kind of geometric, kind of close to geometric. Not exactly, but close. We have a couple problems. One is these numbers are doubled. Why are they doubled? Does anyone know why these numbers are doubled? Why are they doubled? Because it bounces up and down. So if we could get rid of the doubling, we might have a chance to have a geometric sequence. So I'm going to rewrite this, just this doubling part, as this. And this is just saying, instead of doing 3 plus 3, I could do 2 times 3. Instead of doing 1 plus 1, I could do 2 times 1. Instead of doing whatever times plus whatever, 2 times whatever. And then, of course, we have to, as George says, add the 9 outside here. And the reason the 9 is not inside is because the 9 is not doubled. Now, in here, it's a different color. In here, just the brackets, forget the 9, forget the 2, just the brackets, we have a geometric sequence. 3, 1, remember 1/3 was next, where r equals 1/3. So this part is a geometric sequence, which means that I can write the sum of this black part right here. Let's write the sum of that. We can do it here. So the sum of just this part, not the 9, not the 2. Sn equals A1, 3, because we're just doing this inside part, not this, times 1 minus r to the n over 1 minus r. Again, this is just here. Haven't done this yet, just there. So questions on that? Let's simplify the black part a little bit more. Nothing too crazy, just rewrite it as this. And if this is this part, then to find the total distance, remember this was the total, to find the total, we would need first term plus 2 times this. So this should be the formula for the distance at any bounce. So questions on this so far? Now, anytime you create a formula, you should check and see if it's actually correct. So let's just plug in 1 here, and we should get 9. I'm going to plug in 1 and just make sure I get 9, and then I'll be all set. Then I'll be done. So if n is 1, one-third to the first power is just 1. So 1 minus, sorry, 1/3 to the first power is just 1/3. So what do we get here? Well, this is 9 plus 2. 1 minus 1/3, that's just 2/3 divided by 2/3. These cancel out. And I get 9 plus 2 times 3, which is 15. But I should have gotten 9. I should have gotten 9. So this formula is wrong. Where did the mistake happen? I did. Why is this formula wrong? And here's the hint I'll give you. Here's the hint I'll give you. Here's the hint. When I plugged in 1 into this formula, I got 15. If I plug in 2, I would have gotten 17. I'll tell you that. I plugged in 1 and I got 15. If I plugged in 2, I would have gotten 17. Where's the flow? Alright. 2. Go for it. So there's some flaw here. And do you have a comrade? Here?
Yeah.
Okay. Edgar?
Why didn't you have multiply only by the 2?
That would be 6. Here's the flaw. But 1 minus 2/3, sorry, 1 minus 1/3 is 2/3 though, so that's fine. Where's the flaw? Anthony?
Don't you multiply 9 by 1/3?
If I multiply 9 by 1/3, that would give me 3 plus 6 is 9. Why would I want to multiply the 9 by 1/3? Say that again? So then it'll work out? But remember, when I wrote the formula, the 9 was outside here. That has no effect on the 1/3.
Because